Hello, welcome all. Today we are tackling a HackerRank problem called minimum distances. This is an easy difficulty problem, and as usual, I'll go over the problem, give you some time to do it on your own, and then go over my solution. Here we go. The distance between two array values is the number of indices between them. Given A, find the minimum distances between any pair of equal elements in the array. If no such value exists, return a 1. Given an example of A being 3, 2, 1, 2, 3, we see that there are only two matching pairs, the number 3 and the number 2. 1 has no value there. And the distance between 3 is 1, 2, 3, 4. And so that would be a distance of 4 for that. And between 2 and 2 is indices 1 and indices 3. And so 3 minus 1 is 2. And so the answer here is the minimum distance is 2. So that's how that works. I'll give you some time to do it, and then we'll come back with my solution. So to tackle this one, my algorithm was to essentially loop through the list one time and gather all the information I need, keeping track of the minimum distance seen thus far, as well as keeping a storage of the indices and the values seen in order as well. And so I have listed out my algorithm here, but I think it's easier to just kind of show you how this thing works. So here I have an example of a list with 713417, and here I have some variables that I would establish, the minimum distance seen thus far, as well as an object that's going to store key value pairings that we'll see while we loop through the list. We're going to currently be at index 0, and because this is the first time we've seen it, we're going to say, okay, we don't really have a min distance at this point, so we'll just add 7 to our object here. The number 7 has been seen the last time at index 0. So that's what that means. Then we'll go on to the next index 1. And same thing kind of applies here. We've never seen 1 before. It doesn't exist in our little object here. And so we'll also add it there. We don't have a min distance at this point. When we get to index 2, value 3, same thing. We haven't seen it before, so we just add it to our object. When we get to index 3 or value 4, basically same thing. We're back to just adding it. All right, so now that we get to index 4, we actually do see a number we've seen before, the number 1. And here we can just go back to our object and say, okay, you can check to see what was the last index that we saw this number at. And in this case, we see that was the number 1, or the index 1. So we look up via the key number 1, and we see the index happens to also be 1. And here we can actually calculate, okay, what's 4 minus 1? It's 3. That is less than our current min distance, which I've set to infinity. And so I'll set 3 as our min distance so far. I'm going to update my object to include the now current index of 4 for the key 1. And we get to the last index of 5, and we see number 7. It exists in our object, so we check it, and 5 minus 0 is 5, and so that is not less than our min distance so far, so we won't count that. Technically, I do update this to include the 5 as the index, but we're at the end, so we're actually done, and we will calculate our min distance of 3. All right, let's look at the code. All right, so today I'm actually in JavaScript land. I hopefully explained it well enough that you can take this to any language. I'll start off by establishing my store where I'm keeping the numbers and their indices, the last index they existed at. Here I'm establishing my min distance variable where I'm setting it initially to infinity because every number is smaller than infinity. So it's going to be very easy to beat. Then here I'm just looping through each index that's possible in the array A. I'm grabbing the value here and just checking to see if that value exists within my store. Then I know it's been seen before, and I need to grab that value and do my assessment essentially. So what I'm going to do here is I'm going to grab it from the store and then say, okay, my current index minus that last index is the current distance, and I can check to see if that distance is less than the current min. And if it is, I just reset it to the current distance and just keep doing that. I also go into the store and I update whatever the index is for the current value. Then I can, at the end, just check to see, hey, did the min distance actually change? Is it still infinity? If it is still infinity, that basically means that each value was unique, and so I can just return -1 for that. Otherwise, I do have a min distance, and I can return that. Let's run some code. Okay, great, and let's submit some code. All right, very good, very good. Let's look at some time complexity. I don't think there was anything too crazy here. I did just loop through the list one time, and that was it. And all this stuff is just lookup. This is just Boolean checking and just more math, and there's nothing else here. All this stuff is just checking. So in the end, all I'm doing here is doing big O of n, and that's basically it. Whatever the size of the list is, I'm looking at each element one time, and that's it. Total time complexity here is big O of n. That's basically it. All right, folks, if this is the kind of content you enjoy, please make sure to like, subscribe, do all the good things, and I'll see you next time.